Yes, sir.
Okay,
Yes, sir.
good. We said deep slip faults are what? What are deep slip faults? It's not just saying yes, sir. What are deep slip faults?
There are faults with movements parallel to the direction of the
Parallel to
fault.
deep. Okay. Deep of what?
To the
Parallel
deep of the
of the what?
of the
Of the
fault.
fault plane.
Deep of the fault plane.
Good. All right. There are two types. What are they?
Reverse fault and normal fault.
All right. Good. Now, what I was trying to show you in our previous slide is that deep slip fault generally affects map pattern. I want you to know this. They affect map patterns of rock units. Deep slip faulting in the region of subhorizontal strata will result in map patterns juxtaposing younger rocks against older rocks. All right. So let's think about normal faults. All right. Let's think about normal fault. Which is the hanging wall and which is the footwall?
The hanging wall is one that's going downward.
Number two is the hanging wall. Number one is the footwall.
There are two blocks here, 1 and 2. Which is the hanging wall? Which is the footwall?
Number 2 is the hanging wall. While number 1 is the
footwall.
Number 1 is the hanging wall.
Number one is the hanging wall. While number 2 is the footwall.
Number 1 is the hanging wall. Number 2 is the footwall.
Number one is the footwall. Number 2 is the hanging wall.
Number 2 is the hanging wall.
You both should not fight.
Number 1 is the hanging.
Number
one is the hanging wall. Number 2 is the footwall because the normal fault, the hanging wall.
Is the footwall. Why number 1 is the hanging?
Number 1 is the hanging wall. Number 2 is the footwall.
Take it easy. We are not fighting. The hanging wall rests on top of the what?
What about the footwall?
Of the fault plane.
On the fault plane. So in that regard, which one is the hanging wall and which one is the footwall?
Number 1 is the hanging wall. Number 2.
Number 1 is the hanging wall, and number 2 is the footwall.
Now, what I was trying to tell you on that previous slide is that when you erode, all right, this upper portion, all right, you erode this upper portion, you are then left with this. Okay? You can see that the young or the younger rock is juxtaposed against the older rock. Okay? But when you're dealing with a reverse fault, okay, you will see that the older rock, because it has moved, the hanging wall has moved up related with footwall, the older rock is juxtaposed against the younger rocks. All right? So this block diagram shows us before and after erosion. All right? You have A, normal faulting, B, reverse faulting. Hanging wall of the normal fault shows younger rocks, okay? And then the reverse fault expose older rocks in the hanging wall. I just wanted you to see how this plays out, especially on a map, because on a map, what you're going to see is that you're not going to see 3 dimensions on a map. A map is a 2D dimension of features on the Earth's surface, right? So this is exactly what you're going to see on a map. This 1 and 2. So it is impossible to tell whether a fault is normal or reverse from the map pattern alone. All right? If the depth of the fault plane is unknown. Okay? In this example, the map pattern are similar after 180 degrees rotation about the vertical axis. So if you don't know the depth of this fault plane, all right, it's difficult to tell, all right, whether you're looking at a thrust fault. So all I want you to see is your eyes view will be this. Okay? You must know the orientation of this fault plane, okay, to be able to determine if you're looking at a reverse fault or a truss fault. I just wanted to bring this to your notice, and that was why I tried to look for this. And this is for horizontal beds. Horizontal beds, all right? In a case where you have what you call, this is homoclinal beds, so beds that are not horizontal, right? You might have a different kind of problem. So strata deepen uniformly may be dislocated by deep slip fault in two different orientation. Okay, so the deep slip fault may either be parallel to the deep right of the strata. Okay, so you can see the deep slip fault. All right, so this is the fault. Okay, this is the fault. All right, so the map pattern in A includes a repetition of the stratigraphic sequence. All right, so let's say you have a fault in here. So this is the marker horizon, this black. All right, and all of a sudden you have a fault here. What you're going to get is that after the erosion of this unit here, you're going to have a repetition of this marker bed like so. So in A, you have a repetition of the stratigraphic sequence like you see here. All right, but in B, look at the orientation of the marker bed and look at the fault. You then erode this top part off, okay? What you're going to get as final will be this. So in the final pattern in B, all right, it includes lag, missing strata. The black marker bed is not seen in the mapped alpha faulting and erosion. All right, in both cases, these are, normal faults, but we're saying that they will appear differently on a map if the bed is horizontal or homoclinal, that is at an angle. The other thing I wanted to show you is that, again, for homoclinal bed, remember we said the deep slip fault may either be parallel to the strike of the strata, or it could be oblique to the strike of the strata. So this is an oblique fault to the strike. This is the strike. It's striking in north direction, and if it's oblique, it's going to do this. Okay. So again, for the A diagram, okay, you have the faulting, and then you have the erosion of this unit. You can see that instead of it being repetitive, it's showing that it is displaced. It is displaced because of the oblique nature of the fault movement. Okay, if it wasn't oblique, what you're going to have is that you're going to see a continuous marker bed here. But because of the oblique movement of that fault plane, all right, you have it being displaced. Okay, so the strike separation would be misinterpreted as a result of strike slip fault. So this would be misinterpreted that you are having a strike slip fault that is oriented in this direction, okay? But in actual fact is a normal fault that has separated this marker bed because of the oblique slip movement on that fault plane. And the same holds true for the second example. You have a marker bed that is oblique to the fault, all right? And then you erode this portion, and you arrive at this. This is not as a result of strike-slip fault. It's as a result of the oblique movement on that fault plane. Please take note of that. All right. I just thought to show you these examples. It says A to C, three-stage perspective of a diagram that is pre-faulting. Okay, so on a map, you can have complicated issues. So this is before faulting. This is A. And then you have faulting. Okay, look at the marker beds there. And then you have erosion of that surface. This is what you get. Okay, so this is pre-faulting, post-faulting, and post-erosion, showing deep slip movement on a traverse, vertical fault through a sandstone bed, and an oppositely dipping igneous dike. I'm just showing the possible variations. And the other thing I want to end up with here is that there are various ways you represent faults on a map. Okay, various ways you represent faults. What does U stand for again? What does U stand for?
Showing
Up.
Up thrown, and D is down thrown. All right? D is down thrown. And then when you see this sort of thing, this tick mark here tells us, where the fault is dipping towards. So it's saying this fault, for instance, is dipping towards the northeast, all right? I mean, northwest, 60 degrees. This is dipping towards the east, the south, how many degrees? Oh, no one is talking to me again.
50.
All right. And this tells us we're looking at a strike-slip fault. A strike-slip fault. All right. And this, where you have like this with a sawtooth, like small triangles on it, it tells us we're looking at what? A thrust fault. Okay, a thrust fault. And sometimes you can have an arrow showing you that you're looking at a reverse fault. Okay. So I just wanted to show you all of this because when you now transition to begin to look at these faults on map, I want you to have an idea that you can see all sorts of complicated orientation on maps. All right. So it's important for you to know. All right. Any question? All right. In the absence of any other question, I will talk to you again same time next week. Next week, we're going to be looking at folds